in a little bit. Still plenty of stream left. But if you're out, I'll see you later. See you tomorrow. But yeah, be back in a moment. All right. Let's see. Let me start getting these Space News links compiled up here. Welcome to Space News, everybody. The news cycle has been actually kind of slow this week, to be honest. And, you know, that's not the worst thing because it gives me more time to play games. You know, as much as I want to sit here and just news all day, you know. Stormcrasher, what are you saying? I learned that the 73 Targa Florio running racers had to deal with traffic and the roads being in use during the race. Yeah, there's a reason why they stopped doing it shortly after that, but yeah. It's pretty dope. We do seem to have a rocket launch, though, happening pretty soon. Alright, let's see. Alright, got that, Vasya, thank you. I play KSP, but I can't seem to do a rendezvous, so I got Kerbal stuff in orbit. You got a Kerbal stuck in orbit, yeah. I got you. The Soyuz launches in an hour 34, okay. Dank memes. Oh. Dank memes are always welcome. Tori Bruno didn't say that. Ark, he's much too classy for that, but memes, so. Terrier improved Malmute in 11 minutes. What is that? That's the sounding rocket out of Wallops, is it not? Yeah. Yeah, it is. Oh, well, shoot, look at this thing. Look at it, look at this thing. NASA, don't you dare left channel me. NASA. Yeah, Ark, that's what, yeah, okay, I got it. Oh, look at this. Look at that little guy. Oh, that little guy? I wouldn't worry about that little guy. Terrier improved Malmute. Well, you know what? We got some time on that. So, Thomas, give me a 5-minute count. Let's see what else we got. So, big news coming from Firefly. Big news. Check this out. Let's peep this.
O2's 3%.
15.
Water pressure clears the abort.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Burn, baby, burn.
O2's 9%. Diverter looks okay. Plan looks good.
Bro, what is
O2.
this?
Give us
What
a
is
count,
that a
please.
camera of?
14.
Plus 15.
16% on O2.
Made it all the way.
Hey!
O2's 3%.
Hey! Burn, baby, burn. Yes! That's money. What are we looking at here? Oh, it's the engines. Okay, there's the 4 Reaver engines. Got it. So this is Firefly Aerospace. They did a successful static fire of their first rocket here. That's Alpha. That's the real deal.
Bro. Burn, baby, burn.
O2's
Burn,
9%.
baby, burn! Who was that?
That's
We
good.
gotta figure out who that was and give him a
12%
high
O2.
five.
Give us
That's
a last
awesome.
count,
14.
Plus 15.
please. 16% on O2.
Made it all the way.
Made it all the way. I'm seeing a little bit of green there at the end, though, Thomas. You see that? Another rocket company. This is a Firefly Solar. Firefly Aerospace, dude. They're, so, Firefly is, they make, obviously, the Alpha rocket, right? But they're working on a bunch of other things, too. Firefly's working on landers for NASA, for the Commercial Lunar Payload Services program. They're working on landers. They have the Alpha rocket. I mentioned that already. They have hypersonic test articles for hypersonic flight. And they, what Firefly, like, with small sat launchers nowadays, you can't just, it's not just building a rocket anymore. Everybody does that nowadays, which is kind of an absurd thing to say when you really say it out loud like that. All these different small sat developers are trying to distinguish themselves, or small rocket developers are trying to distinguish themselves from each other. So Rocket Lab is moving to making like Neutron now, right? Relativity is looking to 3D print their Terran and Terran R rockets, and Firefly is trying to, what they're trying to do is they're trying to mass produce supplies. They're trying to be like a McMaster car for rocket parts. If you don't know what McMaster car is, ironically, a lot of people buy parts for rockets off of McMaster car. They sell like fittings and plumbings and hoses and valves and stuff like that. Oh my. So Firefly is trying to set themselves up as a rocket supply contractor as well. Yeah, think of it like Summit Racing if you're a car person, but for rockets. That's what they're trying to do. So Firefly's actually really cool. Just on a side note, they watch the stream. I know that some of those folks watch the stream, which is pretty cool. Hi guys, congratulations on the test if you're seeing this. That's awesome. That's so difficult. That's what you're seeing here. Like, okay, I get it. Oh, another rocket. This is the culmination of freaking hours upon hours upon hours upon hours of development, and then a freaking 1,000 million hours after that. It's ridiculous. The amount of effort that puts in, you can't even quantify it with a number. This is so damn difficult to do. So the fact that we're just seeing rockets pop out of the woodwork is pretty damn impressive, dude. More! More! It's been out there for a little bit, Pigsy.
3, 2, 1, 0.
Do you purge? Look at the vibration.
O2's
Burn,
9%.
baby,
Rotor
burn.
looks
The
okay.
ice freaking
Plan looks good.
falling off there. So this is the bottom of the rocket right here. Not Terran R. Alpha has 4 Reaver engines in it. They're Carolox motors. There's 4 of them. There's 1, 2, 3, and then you can just see the other one over there. That's at least 10 hours of work. Rocket Renaissance, for real. First time a rocket is lit there since IceSat 2. Yep, this is Delta 2's old launch pad. That's right.
Give a plus count.
You can see the old, that's where the service structure was at one point. This is out at Vandenberg Air Force Base. Yeah, they redid it. T-minus 5 minutes and counting. So, I'm super, that's really freaking cool. I'm super psyched for them. It looks like they completed their test, and then, guys, the next thing to do, that's the static fire. The next thing to do is launch it. They're targeting about 2 weeks from now, give or take, September 2nd for launch, so that's pretty friggin' cool. Anyway, speaking of rockets launching, there's one launching right now, so here we go. This is a Terrier Improved Malamute sounding rocket launching the RockSat X mission. Which consists of student payloads from 8 community college and university teams that will launch on this. This is a suborbital rocket. This one isn't going to go to space. Terrier Improved Malamute is basically a bunch of missile stages just kind of stacked on top of each other. And it's going to fly as fast as a missile. Yeah, it's going to go. It'll be gone, and then you'll just see a cloud of smoke.
Go for it, man.
This is at Wallops.
Because we don't have a final wind-weighted setting, and I recommend holding at 3.
This is not going to go today. Remember when I just said that it's going to go and it's going to go quick? Yeah, that's not happening. They just called a hold. They just called a hold.
ROA's ready.
ROA final wind weighting settings are azimuth 90.8, elevation 83.1.
Left channel.
Azimuth 90.8, elevation 83.1.
Hold on.
Good copy.
LC is ROA.
LC, go.
I have updated settings for you. Azimuth 90.8, elevation 83.1.
Left channel, guys. I'm sorry.
50K launcher is set at 90.8 azimuth, elevation 83.1.
Good readback.
So what they're doing is they're turning the launcher.
Yes, we are proceeding.
Oh, okay. Hold on. Hold on. Maybe that was just a call for the for what to say if it does hold. The launcher just moved a little bit.
Waiting settings
See,
are azimuth.
here, look. Watch the difference between this and the live frame. Watch the launcher. They switched it. So this is because this is basically a missile. They have to. This rocket doesn't have any guidance systems on it. They have to point it in a different direction. Watch up here, relative to the antenna when I hit the live button. Ready? See it moving? See that? They're moving it around.
Go ahead, Femino.
Port TM lock. Verify,
TM lock.
verify no change in TM signal strength or deviation.
TM is unchanged.
Verify chart recorders are nominal.
Charts are nominal.
Confirm no change in transponder on internal power.
Do it again? How close are those people?
PTM. No change on internal.
500 meters.
PLC
It's
check
just
186.
it's just the
PTM check 181.
perspective on the camera. They're a little ways away.
Elevation 8.
So DV, watch
We don't have a
Rated
watch
setting.
the launcher. See, this is a little more exaggerated, but see, look, they moved the launcher. They set it for a different flight azimuth.
LC, Starway.
LC, go ahead.
Can I get confirmation on
SCS
setting?
185.
I know about the left channel side. There's
Settings
nothing
are
I can
in.
do about it.
Elevation 83.1. Azimuth.
It's annoying.
90.8.
Check 174.
DV, did you see it that time?
Payless stations, this is MM polling for status to proceed to launch. ACS,
ACS go.
PLC,
Attitude control
TLC, go.
systems.
PTM,
PTM go.
SRPO,
T-minus 1 minute. SRPO is go.
MM is go. NASROC Payless status is go. Check 187,
Very
188.
pointy. This thing's gonna go fast real quick, Zubaski.
50.
Real quick. Guys, they don't even need to put this rocket straight up. They can tilt it
40.
because the TWR is gonna be like, yeet! Okay, coming up on 30 seconds.
30.
This is live. Yep. So this is the Rocksat X. It's university payloads for high suborbital testing.
20.
20 seconds.
ACS 195.
Launching out of Wallops. So the Antares pad is that way. It's behind us. 10.
10, 9, 8, 7, 6, 5, 4,
Send it.
3, 2, 1, 0.
Bye-bye. See ya.
6,
7,
track,
8 meter auto track.
9, 10.
9 meter auto track.
Come on, upper stage. It's going to coast for a second.
Tracking.
Yeah! Dude, that's sick. Go, baby, go!
Good job, TM. Good job, radar.
Plus 30.
Wait for it. What are the G's on that thing at launch? Yes.
Plus 40.
That was cool, man. I think that was it.
50.
I don't think there was another stage. That thing looks ballistic. No guidance
Plus 1
systems.
minute.
No guidance systems on that thing, Vin. They spin stabilize it. What is it for? Left side of the screen, Cy. It's just university experiments. Ludicrous speed.
Separation
Go!
and de-spin.
Okay, they're gonna de-spin.
Splash on the booster.
Man, the first stage went up and down real quick.
Nose cone separation.
Hey. It's basically a missile with some science payloads on it, guys, with another missile stage below it.
Radar 3 is now on the payload.
Okay. That's cool, man.
Plus 2 minutes.
TD, RSO, LPM on channel 1.
Go for TD.
Yes, sir. I'd like to get the fire department down here just to put out a small grass fire.
Copy.
Technical director just called the
Yeah, so you good with
range
that?
safety guys and told them to call the fire
RSO
department.
confirms.
It looks like they lit the ground
I've
on
already
fire.
called it in. They're on their way.
Whoop! We lit the ground on fire. Oops. Yeah, you can get the fire department out there. It's fine. It's fine. Everything's fine.
Three minutes.
Saw that building just a few days ago. There you go. Did you realize it had a rocket inside of it, Vulcan? It's pretty cool. So did it blow up? No. The thing was only supposed to go up and go right back down, guys. It wasn't going to space. This is a high altitude suborbital rocket. So basically go up there quick and then it comes right back down. Small fire, amateur. Yeah, right. Ah. What do we light on fire? Anything? I don't see anything on fire. So it's pretty cool. This launcher can actually turn, right? It can turn like this, and then it can go up and down like that. And when it does, when it's in the stowed position, right, it turns this way.
SRPO.
Hang on.
Go ahead.
We did get separation, sir, correct?
We're looking into it.
Uh-oh.
Thank you.
So this thing actually turns, and then it comes back down, and then see this bar right here, that horizontal bar? That actually goes right here. And then the hangar is actually on rails. That's what this foundation is for. The hangar actually rolls over the entire pad, kind of like with the K-33. It's the same thing. Yeah. That guy was asking for confirmation of separation, which is that's not ideal.
SRPO, VTM.
Go ahead, sir.
We did get aft skirt separation.
Thank you, sir.
Aft skirt separation. Aft skirt. Interesting. What is this? This was a Terrier improved Malamute. You want to see it? You want to see it go? It went pretty fast, man. Watch this. This is cool.
4, 3,
Watch.
2, 1, 0.
Yeet!
Plus 1, 2, 3, 4.
Yeah! Fly!
8 meter auto track.
Look at that. It can coast for like 20 seconds. It doesn't matter. It doesn't matter. Don't blink.
Multi antennas tracking.
And then, yeah, go!
We're just tracking the booster.
That's the best, man. That's so funny.
Good job,
I love
Tim.
it.
Good job, Radar.
It reminds me of the rockets that like Wile E. Coyote would strap himself to catch the Roadrunner. Meep meep. You know. That's awesome. I want to see it again. Hold on.
6, 5, 4, 3,
Oh, okay.
Because I didn't get to
1,
say hi to you on your
0.
break.
All right.
1,
But I'm
2,
on camera ready.
3, 4.
Okay. Here. I'll go back to live here. I'll be right back. One
Yes,
second.
sir. We need launcher measurements, or are we clear to bring the launcher down?
I'll be right back. 1 second. You chat. You guys tell me what happens here.
I'll wait for SRPO.
Let's stand by on that TD.
Heat shield deployment. Readout, do you have lock?
Roger, have good luck.
Copy.
PM, SRPO.
Go for PM.
Do we have a apogee from radar?
Wait 1. RCPM.
Stand by, please. PMRC, that's in work.
Copy, standing by.
All right, anything, guys? Hand. Let me give you a hand, chat. Heat shield separation. They're getting to the apogee now. Man, that thing coasted that long to AP? Dude, that rocket really had a lot of kick. They launched another one real quick. Where?
PMRC.
Go for PM.
Yeah, that's 519, 545.2 feet.
Okay.
That is 519,545.2 feet.
Good readback.
Copy, thank you.
They have launched
SRPO,
within
you
2
copy?
seconds of each other before, though. Yeah, you see this building right there? That's another launch pad. Yeah. Wallops does a lot of small rocket launching, guys. Antares is the biggest rocket that goes out of there, with Electron, like, in a close second. But, yeah, they do a lot of these small sat tests, or small rocket tests, where they send stuff up and bring it right back down. It's actually really cool. About an hour, DV? So what's the point? Well, this had student experiments from colleges and universities. That's it says it over here, RockSat. So it was something that these students for like a thesis or something needed to test in the upper atmosphere. These rockets are a great way to get something up there real quick, do a science experiment, and come right back down. Does it cross the Kármán line? Probably not. This one, a Terrier improved Malmute? Probably not. No. There's bigger sounding rockets, though, dudes. There's the Black Brant 12, which is literally a bunch of missiles.
MMACS. Last pressure reading before LOS.
Uh-oh.
229.3
Here,
PSI.
check it out. So, there's Black Brant 12, which is just literally a bunch of missiles stacked on top of each other. This one, the last time we saw them launch a Black Brant 12, it hit an apogee of 400 kilometers, about 270 miles that way. So that, I don't think, so this is what we saw launch here. Terrier improved
ACSPM.
Terrier improved Malmute right here. This is what we saw launch, number 29 right there. That's the big one though. And it's, like I said, it's literally just a bunch of missiles.
Yes.
They use missiles
Can we
as
back that last
stages,
pressure reading?
which is actually really cool. It's really neat. So just
Last
above the
pressure
space
reading,
station, about the same.
229.3.
About the same, but the space station wasn't going
Copy,
past.
thank you.
They're not going to do that, but yeah, pretty cool. Like, it goes from like model rockets to like, I mean, this thing, once again, this thing's about 20 meters tall. That's a pretty big rocket. It's pretty big. Black Brant's a cool rocket. Yeah. It's neat, man. They're neat. These things are cool, dude. You know what's weird? All right, we can flip off of it. We'll go back to space news. You know what's bizarre about that? Model rockets never used to do it for me. And then I said I asked chat basically to change my mind, and they did. I'm like, yeah. All right, those are cool. I dig it. This one did go past the Kármán line, 150 kilometer apogee. Well, there you go. Might as well use missile motors. They're all surplus from... It doesn't matter which one, Tessa. We just run a lot of surplus. Joe Barnard helped. Yeah, a little bit. They never really used to do it for me, like, at all. But, yeah, they're cool. I dig it. All right, anyway, back to other space news. So let's go across the pond here, and let's see what else we got. See what's going on over in Russia here. Speaking of sounding rockets, a Japanese S-520-31 sounding rocket launched the first rotating detonator engine. Oh. It worked? Wait, did it work? No way. A rotating detonator engine. Well, I'm going to get a lot of questions today about this, aren't I? How much money did you make? About 20 G's, someone. I put a lot more, I added a lot more things to the ship, so I probably, and I built a couple of crafting benches, so I probably have, I don't know, I probably made like 40, 50K off of that. Web release. Web release. The world's first successful detonating engine. World's first successful detonating engine space demonstration experiment for deep space exploration by sounding rocket S5 2031. A rotating detonator. No crap. Don't. Government loves surplus. We're still using the Purple Heart medals that were made for the planned invasion of Japan in World War II. We would have, yeah, Staples. We would have had a lot of those. Yeah, I'm really happy that that didn't happen for both sides. Yeah, that would have ended poorly. Detonation engine. Yeah. What kind of engine is that? Okay, so that's a rotating... It's a rotating detonation engine. Alright, so in a convergent divergent rocket design, so basically just picture a rocket engine. You have your combustion chamber, you have a throat that looks like two funnels kind of stacked up next to each other, and then you have your nozzle, right? The thing about that is that a regular convergent divergent rocket engine uses combustion, just like a car. That's why I use cars as an analogy all the time, because what a car does and what a rocket engine does is not that far off. They're pretty similar. Seriously, they're both internal combustion engines. Yeah. So the thing about a combustion engine is that when it explodes, when you take your reaction mass and you put it in the combustion chamber, so you mix liquid fuel and oxidizer, it atomizes and then you light it on fire, it has a very energetic reaction. When it combusts, right, the molecules are still moving subsonic. They're moving below the speed of sound. That's the difference between combustion and detonation. Okay? And then when it combusts, it gets forced through the nozzle, right? It gets forced through the nozzle, and that's when it speeds up past the speed of sound. So the gas is getting expelled out of a rocket engine when they go through the throat, which looks like an hourglass or two funnels kind of stacked against each other, right? That's when it breaks the sound barrier. It goes faster than the speed of sound through the throat. That's what makes the rocket engine work. Accelerating the gases away from the rocket motor at beyond the speed of sound. And then they go subsonic again when it goes out the nozzle. All right, that is like rockets 101. If you don't understand that, you're not going to understand how a rocket engine works. So, the difference between this and a combustion engine, this is a detonation engine. So, instead you're detonating something. Once again, when you detonate something, the molecules moving away are going faster than the speed of sound. That's what the difference is between detonation and combustion. A detonation engine, well, I don't think I need to tell you why that could be better for rockets. Yeah, with a detonating engine, you can make some pretty dang powerful rockets. So here, there's a video or an image of what this kind of looks like. It's weird. It's weird stuff. Yeah, it doesn't look like a rocket engine, like how we'd think a rocket engine looks like. It's different. It looks completely different. Here, let me see. Is it like Project Orion? No. No, not really. Here, this kind of gets the point across. Cross doesn't have a T in it, idiot. But that's, see, this one is the one that the animation that I pulled up is not really. Yeah. Go through Scott's vid. Yeah. I forget the reason why you need to rotate it. I think you need to rotate it because having detonation happen in one spot makes too much heat, but I forget. I'm going to have to go check. Yeah, we can check Scott's video. That's fine. Here.
Hello, it's Scott Manley.
Scotty!
Recently, there's been news about a demonstration of the technology behind a more efficient rocket engine known as a rotating detonation engine.
Look.
While their design is small and generates less than 100 kilograms of thrust, it's a practical demonstration of a device which is being pursued by researchers all over the world, a device that has been theorized for decades and is predicted to be up to 25% more efficient than the ordinary garden variety rocket engine.
Look at that thing.
And of course, when I say garden variety, I mean the rocket garden at Kennedy Space Center because I don't have any rockets in my garden. Anyway, being able to get an improvement of efficiency of a rocket engine would be great when you consider that switching from a open cycle engine to a much more complicated closed cycle engine gets you a 10% improvement, a 25% improvement would be massive. And detonation engines aren't specific to rocket engines or jet engines. The US Navy would like to use those to power the turbines on some of their ships. So what is a rotating detonation engine and how does it work? And how can it squeeze more performance out of the same mass of propellant? The important word here is detonation, which refers to a very specific combustion process. Now when we hear the word detonation, we associate it with explosions, but not all explosions are detonations. In modern scientific terminology, a detonation is a combustion process where the flame front moves faster than the speed of sound in the material that's burning. So here's a fun combustion experiment I did in my kitchen. I evaporated some alcohol in this bottle and then lit the mixture on fire, and in slow motion you can see the flame front traveling down into the bottle. So the speed of that flame is dependent upon many factors, and it can be made to burn faster by getting the mixture ratio correct, and if things get just right, the flame front can accelerate and start to move faster than the speed of sound in the gas. Yeah. And at this point, the unburned mixture doesn't get pushed out of the way of the incoming flame front, and the flame front becomes a shock wave, where the pressure and temperature rises near instantaneously.
I just want to look at this real quick. So, temperature distribution, and you have pressure distribution here. Oh, wow. Dude, look, okay, so look at the difference in temperature and pressure distribution on the detonation wave. Look at how it jumps. The temperature goes down on that detonation wave, and the pressure goes way high. So, basically, this graph is kind of... That graph right there is quantifying what Scott just did with the bottle, all right? So this is right here.
Lit the mixture on fire, and in slow motion
So right there is going up to the graph, and then right here is where you get that huge deviation on the graph. That's interesting, because okay, so why is that a big deal? Well, if you can make more pressure, you can force that out a nozzle, and yeah, you can make more thrust, and well, temperature's going down. I mean, you get more efficiency that way. Look at this graph. Yeah, right.
It's near instantaneously.
Yeah,
this
look at the
is a detonation wave. So combustion processes with subsonic flame fronts get referred to as deflagration processes, and supersonic shock-based combustion is detonation. Regular jet engines use deflagration, and detonation engines use a detonation. The standout characteristic of the detonation process is that the pressure rise in the shockwave is much, much higher because there's no time for the burning propellants to undergo any thermal expansion. In scientific terms, the combustion is a constant volume process, whereas the combustion in a jet engine is a constant pressure process. So how can the detonation process be exploited to make a better engine? The simplest example of a detonation engine is the
jet.
pulse detonation engine, and one of these was demonstrated in flight in 2008. This is a simple engine that was a long tube with some inlet valves at one end. First there would be a purge of air, and then a fuel-air mixture would then be injected, and as that expanded to fill the tube, you would then hit it with a spark plug which would start the combustion at the base of the tube. And
RB, you see that? It's literally a pulse jet's just a gasoline engine with no piston. It's just a car engine with no piston. It's a car engine that creates thrust. Dude. Now what I want to do is like take like a small block Chevy head and just put 4 nozzles on it and just we should do that. That would be awesome. Make a four-stroke pulse jet. Oh, and hope the neighbors don't complain. It'll sound like gunshots going off. It'll be like tick, 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 tick. Oh, that would be ridiculous. And some very unhappy parents. Yeah, 4-cylinder. Yeah.
And initially it would burn as a deflagration, but then as it progressed down, it became a detonation. And if you did this just right, you could make several pulses per second and get thrust out of it. So this transition was why the engine had to be so long. It actually extended far past the rear of the plane. They looked like big long drain pipes.
Oh.
So the engines in that...
That is literally what that is right there. Okay. Yeah. Okay. Yep, that's that. There it is. That is exactly what I'm describing. It's literally a head from a car attached to 4 combustion chambers, and that's it. It's a 3-stroke engine? I mean, technically it's a no-stroke engine. It's a rocket engine. There's no stroke.
That test vehicle would pulse 20
and somebody
times
already
per second,
did that.
and there were 4 of them, so they had like an 80 hertz pulsing.
Oh, that's
and at this
so
point,
cool.
I should also mention that there are other pulse jets. The V1 missile was powered by a pulsed engine, but it used mechanical slats and it wasn't a detonation. Hell, there's even the U-shaped pulse jets built by Colin Furze, who's also on YouTube, but these are not detonation engines because the combustion isn't supersonic. So in theory, pulse detonation engines can exceed the efficiency of regular jet engines, but the purge and pulse cycle means that it's not generating thrust all the time. Yeah. So, the rotating detonation engine takes this concept and tries to make the detonation a continuous process. Instead of the detonation wave travelling down a long tube, it's confined to travel around a circular cavity. The propellant mixture is fed in along the tube, and it detonates and is expelled at the other. Therefore, the detonation wave travels around this cavity in a circle as long as the conditions sustain it. That's the theory, but of course making it work is the trick. And there's been lots of theoretical CFD models showing how waves might work, how they could be tuned and controlled, but the actual physical demonstrations have been elusive. The hard part is maintaining the conditions inside your annular combustion chamber so that the detonation wave continues to move.
That is, yeah, I remember we read about this right when the prototype was tested. That's when Scott posted this video, but I forgot how ridiculous this actually is. Somebody actually made one and it worked in Japan. That's ridiculous, man. I'm wondering if you can have like multiple injectors. Like, so you have your injector here and the detonation goes this way, right? And it spirals, but you have a lot of expanding gases in here, right? And this is inside of the combustion chamber, right? What if we just had more of these? And I wonder if you could modulate the detonations to make it continuous. Yeah, okay, that's where it's going. All right, cool. At least my brain's in the right place, I guess.
In a circle as long as the conditions sustain it. That's the theory, but of course making it work is the trick. And there's been lots of theoretical CFD models showing how waves might work, how they could be tuned and controlled, but the actual physical demonstrations have been elusive. The hard part is maintaining the conditions inside your annular combustion chamber so that the detonation wave continues to move. Frequently they're working with multiple detonation waves chasing each other, and they all need to move at exactly the same speed. If you get the conditions wrong, then one wave might start to catch up on the other.
Dude, that's so legit.
It's possible that you can have unburned
That's
propellant
so
spill
cool.
out the back and burn there, losing you efficiency, or even worse,
my God, that's
exploding.
so legit.
Or the detonation
look,
wave
look,
could
look.
simply just blow itself out. But the advantages could be huge. An air-fed detonation engine could eliminate many of the moving parts. It wouldn't need the compressor that's typical at the front of a jet engine, and after all, a few atmospheres of compression is kind of wimpy compared to the 100+ atmospheres you can get inside a detonating
Look at the
shockwave.
flame, it's swirling.
It's
Oh, that's
believed
so
that
cool.
air-breathing detonation engines could provide usable thrusts for hypersonic propulsions up to about Mach 5, which isn't possible with conventional jets. So now, many of you probably want to know why scientists have so much expectation of the
Duber.
performance
Hell
of
yeah.
a device that's not really been built.
Where are we? Wait, what's PDE? So turbojet, ramjet, scramjet. Rocket. I love how rockets at the bottom is just like, yeah, it doesn't matter. Pulse detonation engines. Okay. Look at... Wait a minute. A pulse detonation engine with hydrogen, am I looking at this right? It could get up to 8750 second specific impulse? This is Mach number down here. Dude. Using atmospheric oxygen. Okay.
What is the theoretical underpinning for all this hope? And for that, unfortunately, I'm going to have to give you a little bit of a lesson in thermodynamics of heat engines. Now, if you've done physics, you know all this, but there's other people here that might want to know. So a heat engine is an idealized device that takes heat from a high temperature source and moves it to a low temperature sink, while siphoning off a portion of that to do useful work. And a simple example is where you take a cylinder that's closed with a moving piston and you heat the gas inside it. That will cause the piston to move and it will do work. Then you can attach it to a cold reservoir which will cool the gas and the cylinder will retract and it'll also do work. Now, in that process you've moved some heat from the hot reservoir to the cold reservoir, but you've also got some mechanical work out of it. And you can actually figure out the efficiency of the engine by the mechanical work out to the amount of heat transferred. So as it turns out that on some level every engine is a heat engine, and it doesn't matter if it has pistons or cylinders or turbine blades. If you can get mechanical work out from heat flow, it's a heat engine. Even the weather on the planet Earth is a kind of heat engine, as the sun's heat causes gas to circulate and move around.
Or water.
So
if
you
you're
can
in
describe
Florida.
the operation of every heat engine by tracking how its pressure, volume, temperature and entropy change over time. So the simple gas in a cylinder I described is kind of like an idealized Stirling engine. And I have a diagram here which shows how the pressure and the volume changes over time on this. So if we just start at position 1, that's where the cylinder is hot and it's full of compressed gas. So as we go from 1 to 2, the gas is now expanding, the pressure is dropping and the volume is increasing and it's doing mechanical work. At that point you put it in touch with the cold reservoir, the temperature drops down from 2 to 3, so that moves vertically, the volume remains the same. And now because the temperature has dropped, the pressure has dropped, so the cylinder wants to contract and does so along these lines with the volume decreasing and pressure increasing back to the ambient. We end up at 4, where we allow the gas to warm again from the hot reservoir so it rises back up to 1. So that is the cycle of the engine. And you can draw other diagrams that show how its temperature changes with respect to the entropy. The really important thing about these diagrams is that you can actually figure out how much energy is transferred or converted to work by looking at the area enclosed by these lines. So you can figure out the efficiency of the engine by looking at the volume inside there. Yep. So, rockets and jet engines, they use the Brayton cycle, which looks like this. And in this case, the heat is transferred or applied at constant pressure, with the working fluid expanding inside the combustion chamber. So on this diagram, that's steps 3 to 4, where the pressure remains the same, but the volume increases because the temperature is being added. So note that in this diagram, by the way, that it's not a closed gas inside a cylinder. At point 8, you've got the gas being exhausted and then being replaced by fresh inlet air. Now, detonation engines use the Humphreys cycle, which adds the heat at constant volume, which means that instead of steps 3 to 4 going horizontally, it goes vertically. And this changes the shape of your cycle and actually gives you more area to work inside. So therefore...
alright, just in case... You know what,
it's anticipated that a detonation cycle should get more power out of the same heat input. So look, that's the theory, and of course...
Adiabatic cycle means, Shaw, that it's just... Oh, I forget. Damn it. Now I gotta go read RPE again. Adiabatic means ideal in a way, assuming there's no heat leaving. Thanks, man.
Of course, in practice, there are efficiency losses and engineering considerations that push your cycle away from ideal. For example, you might not be able to exploit higher temperatures and pressures because of the materials that you're working with. Or say in the pistons in the Stirling engine, those are supposed to move up and stay still and then down and stay still, but in practice they move kind of in a sine wave pattern, so the real working Stirling engines don't get the same efficiency as idealized engines. So right now, detonation engines have taken a few small steps to being more than a theoretical device. But beyond that, they do need to be developed into real working devices and actually demonstrate that they're able to achieve the levels of power and efficiency that the mathematics suggests.
Well, Scott cut himself off real quick there, that the mathematics suggest by. So, alright, look. You know how so think like pulse jet, right? So that's mag. Each one of these is the detonating pulse, right? So at the beginning, Scott did that visualization with the thing spinning around. That's literally, this is a graph that just shows that. So that's the detonator, and it spins around, and then it keeps going. What? Yeah, see, what Scott's talking about is, so, here, hold on. This part of the graph right there, see that spike right there in pressure in the detonation wave? That's that right there. Oh, yeah. Yeah, I gotta show the pulse jet. Sorry, can you demonstrate that again? Looks like vibration hell. Yeah. But clearly it works because there's one right there. Working. Detonator engines could be a game changer, guys. Oh, that's so cool. Louisa, that's what I'm thinking. Like, Louisa, like a radial engine. Wait a minute. Hang on. Louisa, you think? Huh. So, the hell with rotating detonation. Why not a helical detonation? Why don't we do helical instead? I mean, that's odd. That's clearly the next step where this is going to go. Helical detonation, because you have straight linear detonation, right? Which is the pulse jet, and then you have rotating. Now you got to combine those two together. Helical. You could make it. Oh. You can still have a start and an end to each detonation and the vibration that comes with it. Couldn't you theoretically get the detonations to cancel each other out? Think of like how that, like noise canceling headphones, what they cancel out incoming noise frequencies. You could use the detonations to cancel each other out if you had 2 of them. Or 3, or 10. That's freaking nuts, dude. That's so cool. The rotating one is essentially doing that already. Hack and slash here. Let me draw it. Let me draw it. I have it in my. I have an idea. Okay, so right? No, not RPE. It's not rocket propulsive elements, right? So here, why don't we do? So let me just give you axis orientation. So we have 1 and 2, right? Actually, screw it. Here. No, that's not a good way. You know what? It's probably better to do it in Maya. Give me a second. We need an exclamation point Maya. So, have you seen the transparent carburetor episode on Smarter Every Day? Yeah, STX. Yeah, that's a really good video. Yeah, atomization, STX. Yeah, you could. Destin's slow-mo footage showed the gas atomizing. Did you see it? You see it when the piston goes down and the intake valve opens? You have basically, because there's a throat, because there's a venturi, you have the same amount of volume and the pressure drops like crazy. And because the pressure drops like crazy, it atomizes the fuel. It turns to vapor instantly. Really, really cool stuff. A rocket engine does that. Rockets do that all the time. Same thing. Same thing. Here. It's so freaking cool. All right, here. So how about we have one of these? So, right, give me a cylinder. Okay, so we're in the side view here, and just bear with me here, all right? So how about we do something like this, right? Right? So just bear with me here. I'm just making you guys a rocket engine real quick. I know the expansion ratio looks like poop. Just I'm just going fast on purpose, dudes. and this is just for fun here. All right, so you have your rocket engine, right? It looks terrible. That's a really bad convergent divergent, but it doesn't. That combustion chamber is way too big. Here, hold on. All right, much better. So here's your rocket motor, right? And then up at the top, I'm trying to explain what I have it in my head, but let me just delete those edges so we can see inside of the combustion chamber, so to speak. All right. So, rotating detonator, right, looks, you know, from what we've seen from those models, it looks like this, right? You know, it's more or less a cylinder from Scott's video, not the right. See, and they rotate. The detonators rotate around inside of here, and there's like an arrow spike inside almost. So, what's stopping us from doing? How am I gonna show this? Here, I'll just say that's one of them, right? That's one of the ring-shaped injectors, all right? So that's this part, not the cone necessarily, just that part. Instead of putting that spike there, literally just more detonators and have them all spinning around in here. See what I'm talking about? That'll give you that helical detonation that I'm talking about. How would we do that, though? We'd have to... That would be complicated, man. So on one side you have your oxidizer and your liquid oxygen there, fuel there, and then your sparker is on the opposite side because it rotates. I don't see why that couldn't work. I mean, there's probably a reason nobody's tried this. The sparker is only to start it. Yeah, that's true. If we're working in 3 dimensions, Brandano, we could have multiple injectors and just have it ride the wave. You could have a manifold of injectors at like 12, 3, 6, and 9, and then the sparker at like 10, 30, right? And then and then you just hit it once. There's no way. I don't think we have the material science to be able to hold that inside of there. Well, I mean, we might. I'd have to ask Rocket Guy about this. The problem is getting it to start and take one direction. Starter motor. I'm serious. How? Put a starter motor right here, and that starter motor will go down the center shaft like that, and it'll spin a turbine. it'll spin a turbine, and that turbine can move enough fuel. Or you could have the turbo pump. You could have a tap off of a turbo pump, because you're going to need a turbo pump anyway. Have a single shaft turbo pump on the top, just like Raptor does, and then when you spin up the turbine, right? Have the turbine have an impeller right here inside of the detonator, and that swirls the air for you. Whew. Yes, please take One Direction. Put the UK out of its misery. Hey, you guys need to apologize for that. Yeah, Brendano, that's what we were watching from Scott's video. It's a freaking toilet bowl. It's a detonating toilet bowl. What, Brendano, why don't we just put an M80 in there? And then, wait, no, that would blow it up. Crap. Don't do that. Don't do that, by the way. Unless you want to depth charge a toilet bowl. Dude, that could work, man. I think the problem here is heat, because you have supersonic air going through the throat. If you have hydrogen and you have a stage cycle, dude, a staged rotating. Can you imagine? Stage rotating detonation. That would be. That would make Raptor look really stupid, actually. Yeah. Isn't detonating the toilet bowls the result of a bad time, though? No, Yarg. Okay, so don't do this. This was something that kids did a long time ago, and yeah, don't do this. If you take a toilet and you take an M80, right? And you put the M80 in the toilet, and the M80 goes into the water in the toilet, and then it goes off. It cavitates the water and basically makes a depth charge in the toilet, and the toilet blows up. It cavitates the water inside, but the water isn't compressible, so it just blows the toilet in half. Don't do that. Do not do that. Do not do that. Kids used to do that at school. They throw M80s in the toilet, it blows up, and the toilet blows in half. Don't do that. Do not bring explosives to school. You will get expelled nowadays. Don't do that. Yeah. Oh yeah, I used to do that in school, man. Oh, it's such a bad idea. Yeah, don't do that. Don't do that at all. It's such don't do that. Yeah. It's pretty funny, actually. Seriously, the thing just cracks like an egg, just right down the middle. It's really funny. Does Taco Bell count as explosives? Sure. Oh. I never did it, Shaw. There were kids in my school that do it. I never did. I didn't have the balls to do that. I'm serious. Didn't have the balls to do it. RB got the joke. No, I got the joke. I really wanted to talk about M80s in the toilet because it's really funny. Oh, it's so stupid. Have I seen this yet? No? I don't know what this is. Tessa, what's your last? Oh boy. Slight tangent. Have you seen the turbo Posty bike from MCM? No, I haven't. I haven't watched that yet. Never had the bowls. Right. That's right. All right. So that's cool. That's cool that they tested a detonating engine. I didn't know that. I didn't know that this was a thing. They definitely did it though. I mean, there's a pretty good picture right there. Kind of want to read about it. Okay, what instead of a cylindrical shape, you have a cone shape, like an arrow spike. So as the detonation goes up, the area decreases, And then the pressure increases like a throat, but without heat problems because it's rotating. I mean, that's kind of like what I just said, but the reverse. But yeah, maybe. Fuzilla, yeah, we got a Soyuz coming in a second. The rotary detonation engine operated for 6 seconds at 500 newtons. Oh, that's a little tiny engine. And then the pulse detonation engine, operating for 2 seconds times 3, operated normally in outer space. And the image pressure, temperature, vibration, and position. Okay, we got the data, so they got the telemetry from it. That's what they're trying to say. But the translate doesn't work very well. Cool. The detonation dramatically increases the reaction speed by generating detonation waves and compressing waves at extremely high frequencies, 1 to 100 hertz. Thereby dramatically reducing the weight of the rocket engine and generating thrust easily. The success of this spaceflight demonstration experiment has greatly increased the possibility that detonation engines will be put into practical use for deep space exploration kick motors. That's cool. Oh, kilohertz, even, yeah. Huh. That's cool, man. That's so legit, dude. That's really freaking cool. Ah, man, that's dude. I just want to see somebody make a helical version of it, like what I was talking about. It's going to be in the next RS-8. I mean, Salty, basically, yeah, a detonation engine to a regular rocket engine is like a rotary compared to a piston engine. It's kind of the same in terms of, like, ridiculousness, you know? Like, you know, like, you can get crazy amounts of power out of a turbo 13B. Like, you know, Mazda people will understand what that means. Rob Dom has entered the chat. Going to space. Hydrogen, oxygen, apex seals. What if he... What if you had the rotor spinning inside of the rocket engine? You could separate detonation waves from each other. At least on one axis, right? Rendena, what do you think about that one? You have a rotor inside a circle, not the kidney bean that looks like the rotor housing from like a 13B, right? And you have the thing spinning around inside of a circular inside of the combustion chamber. That sounds overly complicated. And it basically shields the detonation wave from each other, but the detonation wave still goes down. It's a Wankel, but the detonation wave wouldn't push the rotor. The rotor could be articulated on a turbo pump. Or through a gearbox to a turbo pump. A Roots supercharger? Well, I think same idea for the most part, Tessa, but we're not compressing anything. We don't want to compress anything. I mean, those things already can... I mean, geez, how the heck the apex seals? Yeah, you would need apex seals in the rocket motor. Oh god, that would suck. Those apex seals would melt. How is Starbase? Good, man. Good, good. That would mean running a shaft through the combustion chamber. So? So what? If you're running it through the injector plate, Hellfish, it doesn't matter. Most injector plates are bolted on anyway. You got stung by a yellow jacket. Oh, that's good. Isn't that what liquid piston is making? Fuel source in the rotor? I'm not sure. C22. I don't know. Ideally, no moving parts, though it still needs fuel and oxidizer pumps still. What about, like... Ooh. What about an expander cycle detonation engine? You're generating way more heat. You can create way more thrust. The amount of heat that you make in an expander cycle engine means that you can make more thrust. Ooh. Ooh. Would a nuclear thermal detonator engine be possible? Nuclear thermal engines don't detonate anything. They don't combust anything either. No, I don't think so. But that only works when you're in orbit, right? No. Expander cycles can work down here. They work down here just fine. Oh, yeah. Yeah. They can work just fine. They're just really good upper stage engines. But you could make an even better upper stage engine. With a okay, so seriously, rotating detonator with RL-10. An RL-10 with a rotating detonator inside. That would be rotating detonation inside, not detonator differences. Now I want to draw that. Draw it out. That's a good idea. I'm pretty sure that'll work. Anyway. Let's, I want to read more about those later. That's my homework for the night. I'll read about detonator engines and go from there. Okay. Anyway. I'll link up Scott's video if you guys want to learn more too. What if they did that, but the gaseous mix is ignited after a weird stage 2 Nerva hybrid? So, like, staging nuclear thermal with regular? I mean... So let's think. All right, so the nuclear is heating up the hydrogen expands, right? And it generates a ton of power. You can generate electricity that way, and then you shoot the hydrogen out the back. Now, that in a stage detonation with liquid oxygen, so you're basically using a nuclear thermal engine as a turbo pump. You'd have to hit it with some... You'd have to hit that stage, that heated up mixture with oxidizer, and then put it into a combustion chamber. Yeah, the problem is that the nuclear heats the fuel, which is the opposite of what you want for a detonation. But on the back end of a detonation wave, Savvy, the temperature actually drops because Now I'm brainstorming. I'm in brainstorming mode. That's not good. We got a Soyuz launch soon. Yeah, I don't know. I mean, Problem is that the H2 is already superheated. The O2 would cause instant combustion. Yeah, yeah, that's what I'm thinking. Your hydrogen would auto-combust. I think just a straight expander cycle. An expander cycle rotating detonation engine would be insane. Because that, you basically solve your heat problem. The hotter an expander cycle gets, the hotter the expander cycle gets, the more efficient the motor is. The more thrust you can make, more or less. So you could. So the thing about expander cycles is that you have limits. It's how much, going back to Scott's thermodynamics thing, you flow the cold hydrogen over the combustion chamber, right? And that cold hydrogen expands, and then that thermal expansion drives the turbo pump, and the turbo pump pumps the hydrogen and oxygen into the engine, right? You're limited by the surface area of the hydrogen channels that cool the nozzle. But if they're getting hotter, you could make an expander cycle a lot bigger. You could have an expander cycle engine that's a lot larger because you're generating way more heat because of the detonation. Expander cycle is a type of fuel delivery mechanism for rocket motors in Arleon. Long story short, hydrogen hits the hot nozzle, and that drives a turbine, and then it gets dumped overboard. The hot hydrogen gas gets dumped overboard, and that turbine spins, and it spins the turbo pump. It's not a turbo pump. It's just a pump. It spins the pump that pumps the hydrogen in, and then the hydrogen turbine shaft is attached to a transmission, it has a gearbox, and that's attached to the oxidizer pump. So some of the hydrogen that goes into the rocket engine is used to cool the nozzle and spin the turbo pumps. Yeah, expander cycles. It uses thermal expansion from the heat it uses thermal expansion of hydrogen from the heat generated from the cold hydrogen hitting the nozzle. Yeah, it's really smart, actually. They can use hydrolocks, Savvy. You can use hydrolocks or carolocks from what Scott's video said just a second ago. Yeah, I saw it, Blue Shorts. I saw the link. I have it open. Yeah, expander cycles are extremely smart. So in Arleon, what I'm saying is if you have, so they use just a regular combustion engine. An expander cycle is just a regular combustion engine. You spray hydrogen and oxygen in there, they atomize, you blow it up, out the bottom, right? If you switch that to a rotating detonator, right? The detonation creates tons of heat. It creates way more heat. So if it heats up the outside of the nozzle, you're going to need more hydrogen to cool it. And if you need more hydrogen to cool it, that means you can increase the RPM on the turbo pumps. And if you can increase the RPM on the turbo pump, you deliver more fuel and oxidizer, bigger explosion. And because you're using hydrogen, you're already getting great specific impulse. Dude, a detonator expander cycle is actually not a bad idea. So do rocket engines heat the fuel right before the combustion chamber? Sometimes, Savvy. It depends. That's a stage cycle. Yeah, Raptor and the shuttle engine do that. Yeah, that's what makes them so damn complicated. Can you and Scott do a stream on advanced propulsion? Yeah, I'll ask him. I'll shoot him an email. Have they ever made a dual expander cycle engine? What do you mean dual, Brandano? Yeah, controlling the detonation seems to be an issue. But with that helical design or a rotor that separates the detonation waves from each other and it spins around, actually, it wouldn't even need to be eccentric. You just spin it. Or create a turbine that creates a swirl that pulls the propellants down. Putting a turbine in the combustion chamber might end poorly. But heck, that doesn't even need to be in the combustion chamber, dude. It can be before the combustion chamber. This is a dual expander aerospike. That's cool. Man, those turbines would spin really fast. Really fast, dudes. How about spraying the locks right before the diverging section of the engine? I mean, yeah, Hellfish on a nuclear engine, yeah, you could do that. It would be like an afterburner for a nuclear engine. Yeah, sure. But that's, you're talking about a different thing, though, than me. Anyway, here, let's see what we got. Let's keep going. So, check this out. This is coming from the Inspiration 4 crew. This is coming from Jared Isaacman. So, Space Shuttle Almanac posted a picture of this. That's what the Inspiration 4 capsule is going to look like. It's going to have a bubble on the top instead of a docking port. Right? And then Jared Isaacman, the commander of the Inspiration 4 mission, right, says, "We have been tracking it from the beginning. Design and testing in Hawthorne to the systems and training procedures, to the flight-ready hardware that's shipped to KSC. A few weeks ago in the clean room, we saw a fully assembled module with a cupola installed on Dragon. SpaceX is an incredible company." There it is. EJ in chat, theory crafting advanced propulsion elements. Typical Thursday, yawn. I'd have to ask Rocket Guy about some of this stuff. That's cool. Anyway, there's a little bit of Russian news, and then we got the Soyuz launch. Let's see what this one's about. Yeah, Cosmodrome, Vostochny. Oh man, I forget. I forget what the backwards R is. What the hell's the backwards R? SpaceX Resort Space Station coming soon? Yeah, maybe. I don't know what the... This is at... It says at the Vostochny Cosmodrome something else.
На данном объекте сейчас производятся работы по завершению изготовления корпуса вакуумной установки. Вот если посмотреть, сам корпус находится...
Let's try it.
На данном объекте сейчас производятся работы по завершению...
Work is underway at the facility to manufacture the body of the vacuum chamber.
Если посмотреть, сам корпус находится полностью практически собрано. Идет завершающая стадия в плане монтажа патрубков.
They're working on the vacuum testing chambers at Vostochny.
Завершить верхнюю часть и перейдем на нижнюю часть.
Hi, did I miss space news? Hi, did I miss space news? Yep, we're playing KSP right now. Vacuum chamber will be ready in 2022. That's what it just said.
Такая работа относительно Новой России проводится впервые. Раньше такие бракамеры делались для Байконура. Ну, это, собственно, вот мы делаем для космодрома Восточный. Бракамера будет заводиться пилотируемый космический аппарат, будет создаваться вакуум, как в космосе, и будет проводиться испытание на герметичность космических аппаратов.
So they're working on the vacuum chambers that they're going to use to test future manned space capsules. This is at the Eastern Cosmodrome, the Russian way far east. It's actually not that far away from Tokyo, to be honest with you. Sorry, I'm slow today. It's no problem, man. I'm just giving you crap.
Discovery, go at throttle up.
I'm struggling with this stuff today. This is something for space. I'm having trouble. And what does this say? Ernest. Or not Ernest, Everest, I'm sorry. I'm thinking across like 3 languages now. That's great. In before space, I don't think Elon's interested in a detonating engine right now. His whole spiel is to make regular rocket engines affordable. But, you know, maybe SpaceX, I don't know. The reverse R is something like an A. That's a 3. Your head is in the way. That's not what it says. That's not what it says. You're lying. Don't try this at home. Make a vacuum chamber, PY? Yeah, I won't do that. It says music. The 4th word is hehe. Как? It means how in Russian. Hey guys, did you know that Area in Space is live? You should go check it out. They just went live just a second ago. It says something about Ho. Okay, cool. It's the vacuum chamber. That's the vacuum chamber that they're going to use to test capsules and stuff in. Alright, let's... Is it though? PY? I don't know, man. I'm not convinced. Alright, here, let's check that out.
Наших технологических объектов.
Уже на стартовом столе ракету специальным устройством вертикализируют. Каждый раз ее поднимают в тот момент, когда Солнце находится ровно позади. Еще одна традиция. Красивая.
Подготовка ракеты космического назначения с пилотируемым космическим аппаратом занимает 2 дня. В данном же случае подготовка ракет космического назначения с космическим аппаратом OneWeb с разгонным блоком фрегат занимает 4 дня. Это обусловлено тем, что на подготовку того самого разгонного блока фрегат уходит больше времени на обработку телеметрии программного обеспечения.
После вертикализации ракеты в работу вступают сотни специалистов. Все время до старта они подготавливают ракету-носитель к запуску, подстыковывают коммуникации, проводят испытания, выполняют проверки герметичности магистралей, а потом переходят к заправке. Вся телеметрическая информация от ракет-носителей и разгонного блока фрегат через измерительные пункты поступает в ЦУП.
Сейчас мы находимся на
измерительном пункте номер 5. Все наши измерительные пункты находятся на космодроме Байконур. Мы принимаем информацию от ракет-носителей и разгонных блоков. В момент подготовки к старту и самого старта. Надежность наших систем 100%. Телеметрическая информация дублируется с разных измерительных пунктов. После обработки телеметрической информации госкомиссией решается вопрос о готовности к пуску.
Ракета готова к пуску. Скоро специалисты займут свои места в специальном бункере, откуда ведется управление полетными работами. Ну, а до команды «Ключ на старт» осталось совсем немного.
Да. Obviously. Did you guys get all that?
Итак, сегодня, 20 августа 2021 года, мы провожаем в космос с космодрома Байконур ракету-носитель «Союз-2».
We're... Hang on. Let me listen.
OneWeb до старта чуть более 5 минут. Но хочу напомнить, что
The rocket launch will be in about 5 minutes.
отечественного ракетостроения началась тоже в августе. В эти августовские дни только в 1933 году с Нахабинского военно-инженерного полигона была запущена первая отечественная ракета с жидкостным реактивным двигателем. Называлась она ГИРД-9. ГИРД – группа изучения реактивного движения. Один из ее организаторов, Сергей Королев, будущий главный конструктор, основоположник практической мировой космонавтики, в скромной тогда еще газетной заметке по поводу первого пуска писал: «Первая советская ракета на жидком топливе пущена. Этот день, несомненно, является знаменательным, и начиная с этого момента советские ракеты должны летать над Союзом республик». Из современного Нахабина, где чтят историю, Влад Миронов.
Huh. He's talking about Причал?
Сосновый лес, памятный камень, макет ракеты.
Oh. No, I know.
Согласитесь, сложно представить, что 88 лет назад это место фактически стало первым миниатюрным космодромом, с которого полетела первая отечественная ракета на гибридном топливе. Легендарная ГИРД-9.
Группа изучения реактивного движения Фридрих Цандер и группа его единомышленников, включая Сергея Королева, в успехе пуска не сомневались. Ракета тогда взлетела всего на 400 метров, полет продолжался 18 секунд. Но это скоротечное событие стало настоящим прорывом в долгом изучении космоса.
Это группа, которая предопределила будущее.
See, this is the stuff you don't get on the ESA launch. I like listening to
Во-первых,
this.
они совершали то, что никто никогда не совершал. Они решали задачу, которая не имела на тот момент решения. То есть превращали невозможное в возможное.
Многие годы легендарное место находилось в секрете. Тогда, в 1933-м, это была территория Нахабинского военно-инженерного полигона. Но энтузиасты установили точное местоположение пуска. И теперь каждый год местные жители, активисты и ученики Нахабинской школы номер 2, гордо именующие себя гирдовцами, собираются на праздничный митинг.
И сегодня космические корабли бороздят небо наше. А мы храним память о тех людях, которые были первопроходцами. Им было трудно, потому что они были первыми.
T-minus 3 minutes.
Праздничный день не обошлось
We got a live shot up there.
Маленькой модели того самого ГИРДа, благодаря которому сегодня мы можем смотреть трансляции стартов других ракет. Больших, мощных и стремительных.
3, 2, 1, полз!
Yeah. No, Hellfish, no. Not in this launch,
От старта ракеты-носителя «Союз-2-1Б», которая в связке с разгонным блоком «Фрегат» начнет выведение на околоземную орбиту кластера из 34 спутников связи OneWeb буквально считанные минуты.
Okay, we're 2 minutes out from the launch of the Soyuz rocket with the Fregat upper stage launching 36 OneWeb satellites.
Рокот космодрома.
Here's a live view of the rocket. They say the same stuff that they say on the American in the English cast. It's the same thing. All right, here we go. So this is launching OneWeb satellites, guys. OneWeb is a internet satellite provider, internet satellite constellation provider. They're kind of in direct competition with Starlink here, and most of their OneWeb satellites launch on these Soyuz 21B rockets. So what you're looking at there is Soyuz 21B. It's a 3-stage rocket. that could have a fourth stage. This one does have the fourth stage. The fourth stage is called the Frégate upper stage. It is a Hydrolox upper stage that's specifically designed for in-space stuff. It's basically a bunch of fuel tanks duct taped together with a rocket nozzle at the end. Seriously, that's what it looks like. It looks like a donut almost. And then it has the payload attachment fitting for 36 OneWeb satellites. Starlink, VY? What is that? Starlink. I forget. I don't know what that second word says, dude. I'd have to translate it. I will Google Translate it. Smoke. Starlink is cancer. Wrecked. All right, here we go. So the first thing you're going to see here is the upper umbilical arm is going to separate. It's going to pop back, and then that means I think we're inside of 30 seconds. And then at 15, the second umbilical arm will pop back as well. When you see that, you know we're good to go. You'll have engine ignition at T-0, and then separation of the rocket at 6. It's 30 seconds, I think.
Внимание на стартовом комплексе. Команда ВД, автоматическая отмена предстартовой подготовки первой.
Not really, Panta, no.
Входим в работу. Занять рабочие места.
Okay, so the other upper arm is separated. Watch right here. Watch that one. That one should pop.
Готовность стоянки 24 часа первой.
Scrub? Uh-oh. Oh, abort. Wow, that's rare. 24-hour scrub. That's really rare. Wow. Yeah, you don't see that every day. Man, something really must be wrong for them not to send it.
Discovery, go and throttle up.
Hey, an anonymous gifter gifted out 10 subs. Thank you. That's cool. Man. Soyuz aborts? That's a new one. Yeah. Soyuz that couldn't go. Weird. Yeah, that's strange. Cam, I'll be real. I'll be real with you. It's probably like the last Soyuz that we saw scrub. It ain't the rocket. Remember the one that was going out of Guyana? And I was like, it's not the rocket. And then later they were like, yeah, it's not the rocket. And then Dimitri tweeted, he's like, nah, the rocket's good. Just like what Tori Bruno did after the OFT-1 mission. He's like, no, the rocket did exactly what we wanted it to do. It's the payload's fault. It ain't the rocket, guys. Something's wrong with the satellites.
Discovery, go and throttle up.
Yeah, it didn't go. Inside of 30 seconds. Something, they must have really found something. I forget, Kyle. This is OneWeb for sure. Told you in 5 years. Alright, jeez. How do they detank? You probably don't. Alright, what's Nikolai have to say? This is a lot of machinery. What's up, Ramen? Ohio,
Ну что ж, мы с вами внимательно наблюдали за подготовкой к старту ракетоносителя «Союз-2-1Б», которая предстояло вывести на орбиту с разгонным блоком «Фрегат». 34 спутника OneWeb, и поступила информация только что о том, что в штатном режиме дата перенесена на резервную. Следите за новостями на Роскосмос ТВ, на официальных ресурсах госкорпорации Роскосмос. До встречи в космосе.
Yeah, Baroth, right? Automatic sequencer has paused the countdown, standing by for more information. There you go. Didn't we just see this? Look at these planets rotating on the gears. Yeah, see, planetary gear set with planets. I get it. Oh, well. They shut that off real quick. Okay. May I see your t-shirt for a second? Sure. He said I would rather go to sleep. Well, it is late. It's... What time is it in Vostochny? But that one was going from Baikonur, so that doesn't... Yeah, no. I mean, that's still late. Oh, cool. Thanks. Yep. That shirt is tyrannical. I see what you did there. I hope this time they take care to disarm the automatic launch abort sequence. It's a Soyuz 21B. It does not... It's a cargo that doesn't have that. I'm confused. Ariane Space is still going. I'll see if they say exactly what it is before they cut it. Cool, cool. They're still waiting for the launch on the ESA stream. All right, let's go see. Nikolai's like, I'm leaving. I want to go to sleep. До свидания. He's just like, nah, I'm out. All right, let's see. Do we have? They're about to cut? Oh, never mind. All right. Yeah, Brendano, I do remember that. Yeah. So, all right. The last bit of space news here is coming from a Russian space correspondent, and her name's Katya Pavlyuchenko, and she toured the museums at Baikonur, which is actually really freaking cool. This isn't something you get to see every day. Check these out. So, there's a picture of Katya with the NK-33 in the back. That's one of the first oxygen-rich stage combustion cycle engines. They were designed for Russia's moon rocket, and then that didn't happen. You can see there's a picture of the N1 behind her there. Check this out. There's a bunch of sweet pictures. Like, look at this. There's some names on here you guys might know. Let's look around, see what we can find. Oh, Terry Virts. Who else? Who else? There's NASA astronauts on here too. Huh. Oh, Frank DeWinnie. Yeah, that's cool. There you go. That's pretty neat. I'm trying to look through it. I'm trying to read all the different names. Ah! Herr Gerst. Ah, wunderbar. That's Alexander Gerst. He's a German astronaut. Luca Parmentano over there. Max Sarayev right there. That's cool. Dude, there's some pretty awesome names on this list right here. I remember Tori bragging about the insertion accuracy at the press conference. I mean, hey, Oberoth, Tori Bruno does a lot of things, but Tori Bruno does not lie. There's nothing wrong with what he said. The rocket did exactly what it was supposed to do. The payload didn't. Dude, they were able to place that thing in a perfect insertion orbit with its RCS firing in all different directions, and then they yeeted the capsule off, and Tori Bruno's like, that ain't my problem, bro. Fancy signatures. Mine's just a scribble. Did you say Tora Bruno? Not on the wall here. Kate Rubin right there. Some of these are all sideways. Oh, hey, not bad. Skelly. Kate, do I mean Sergey? Yes. Sergey, and Kate Sergey. Yes. Scott Kelly right there. That's really cool. Oleg Artemyev over there. Drew Morgan over there. Oh, this is gnarly, dude. Kjell Lindgren right there. NASA astronaut. That's cool. I'm the guy who does his job. You must be the other guy. Yeah, they sign this before when they complete the, what is it? When they, let me see what Katya says actually, hold on. The museum is located on the Cosmodrome and has a lot of unique exhibits in its collection. The cosmonauts and astronauts traditionally visit it before the launch and leave their signatures on the wall. That's cool. Yep. Oleg Novitsky, Peter Dubrov, and Mark Van Heet. Those are they're up there right now. That's cool. All right, first hall of the museum. What do we got? Oh, this is. Oh, I would enjoy this. Oh, I would enjoy this. Oh, yeah. That's gnarly. Very cool. What else do we got? Hey. I recognize that. The ILS Proton. That's the one that launched Zarya to the space station there. And then there's a model of the LEM and the LK lander. The Soviet lander was supposed to just land one dude. One dude. Where in Russia is this? It's not in Russia. It's in Kazakhstan. Baikonur. This is the museum in Baikonur. That's really freaking cool, man. There's Lunokhod, a drawing of Lunokhod right there. That's the Soviet lunar rover. Man, these pictures are sweet. Imagine being on the moon alone. That's ballsy. But because the N1, so the N1 had more thrust than the Saturn V, if I'm remembering correctly. N1 had way more thrust, but the N1 doesn't have, it's no hydrolox upper stages. It's Karolox all the way up. You really took a characteristic energy hit. That's the difference. That's the difference in landers between an all Karolox system and an all hydrolox. Well, not all hydrolox. The second and third stage was hydrolox. Yeah, pretty nuts, huh? Yeah, the Lunokhod rovers are still up there. Yep, there's a picture of one. That's cool, man. Yep. It's a really nice model of the LEM, if I do say so myself. I wish the Zon program had continued. Yeah. Yep, one dude. This thing was actually, it had a high center of mass, and the Soviets were worried about when they landed on the moon, they were worried about it tipping over. Check this out. Yes, that's exactly what you think it is. They had downward-facing separatrons to get it to settle on the surface. Separatrons for the Kerbal players. They had downward-facing retro rockets that would push the lander into the ground. It's pretty cool. I'll take the LEM. Collections of Soviet pins. Glishko. No, that's not Glishko over there. Oh, yeah. Yeah, it is. Oh, this is money, dude. Yo, what do we have here? Brummel. Yeah, upward. Yeah, sorry, I said downward. Yep. Test capsule. Part of the operator's journal. He said a human is in space, hurrah! And then he tore out the page because he didn't want to get in trouble. Let's continue with the Baikonur tour. So this is from, Katya posted this stuff a little while ago, but she added to it. She added to the thread. She necroed her own thread. Here is the updated stuff down here. Oh, baby. Hello. Do they have the bunny signature? Maybe. That's an RD-107. You were just looking at 4 of those things on the pad on the rocket that's scrubbed. The design hasn't changed much. And there's the NK-33 right there. The hull contains a lot of rocket devices and equipment. Here are some examples of the details of the rocket flight control systems made by the Academian Pyulgin Center. Gyro! Look! An SAS! Oh, gyroscopes. I don't know what that is. Yep. Is that 4-pack thing a thing in KSP? No. John, what the Russians do is they split the rocket motor over with 4 nozzles for better heat control. Yeah, that's why a lot of the Russian stuff has 4, 2, 3, 8 nozzles. Yeah, so you don't need to make some super refined material to make the nozzles. Another Lada engine. There's a gyro right there. Old school gyro. It's in some kind of avionics box. I have no idea what it's for. Here's also some strange exhibits like this box with box of samples of soils taken from the site of a lightning strike. Firefighting equipment. Oh, dude, this museum is sick, dude. I'd go to this. It's out in the middle of nowhere. Oh, there's the firefighter. Yo. Okay. That's real. That's a real Soyuz right there. Oh no. Don't. Uh-oh. There are multi-nozzle engines in KSP ... Yeah, Go, you're right. Nothing like the RD-107 though. But if you want to ... me like that, I mean, technically the Bobcat engine is not a twin nozzle motor like the Russian engine is. It's actually supposed to be an LR-87. An LR-87 is actually 2 engines working as a unit, and it has 1 name. In terms of the Poodle, I have no idea. Yeah, you're probably right. But the Bobcat is not 1 engine. It's 2 engines. It's just those 2 engines working in tandem is called an LR-87. ... Don't you ellipses me, you piece of poop. Alright, this is an AS-12R9 missile transporter. And the container for the warhead. Warhead or payload? The Soviets did build spherical capsules. Yeah, this sphere is not a bad idea. Actually, you know, they learned a little bit later that having a hemispherical heat shield, at least to an extent, will push the plasma out of the way better. The warhead, of course. Yes. Katya just needs to take this camera and just move it up there. Like up there. Not there or there so much, but over there. And that looks like an RD. That's a 0120 back there. Oh, what's that doing outside? No, don't leave it outside. Well, I suppose at Baikonur it's not going to rust. Here's the launch table for the R9 and a 0120 engine for the core stage of the Energia rocket. Why is that outside? Just put a damn tent over it or something, man. Oh, that sucks. So that's it's basically like a Russian counterpart to a space shuttle engine. So imagine how much it would suck to see a shuttle engine just sitting outside, literally rusting. That would really piss me off. Yeah, I'd be like, no, but just put it. I'll take care of it. I'll take care of it. Would a spherical capsule have been a more pleasant re-entry for the astronauts than a regular capsule? Spherical capsules are harder to control because there's nothing stopping them from just doing this, from just spinning. That's why if you look at a Soyuz, it looks like a sphere that's been stretched a little bit, like an ellipsis shape almost. Can you post the thread link? Absolutely. Here, you can get in there from there. No, it's not a bad idea, Nemetko. It's not a bad way to do it. I mean, Soyuz is basically, from the Vostok capsule to the Soyuz is not that. They just literally took the shape and went. That's all. For better control during re-entry. Yeah, it's pretty cool. What else we got? Fragments of the flight hardware of the Soyuz TMA launch escape system, which were found after launch and brought to the museum. Wait. Which escape system? From what launch? Soyuz TMA number 225. Cool. What's the thing next to it? That thing is part of the... Bach, that thing. It's that thing right there. It just hit the ground. It just hit the ground really hard, so it's not really, doesn't really look like anything. You can see there's the different combustion chambers for the solids right there. Next to the engine, it's an that's a R9 missile launch table. It's a launch pad. It looks like Baikonur is fairly dry climate. I mean, none of this stuff is rusting particularly bad, but then again, it is a museum, so they might take care of it. Last, please. I see Titeb. Oh, Firefly. Yeah, we looked at that already, Switchio. Pretty cool. Yeah, what do we got? What is this? This is the DM upper stage, originally designed for the Soviet lunar program. It can now be used by Proton and Angara rockets. Ah. Yeah, it doesn't come with the doors on the side. KSP does have the RD-107. Oh yeah, that's right. I forgot about that. I just never used that thing, dude. But yeah, you're right. There's one engine that's like that. Yeah, I'm wrong. This is an old version of a Proton fairing. Cool. Can we see this part, please, Katya? Please. Behind the museum, there is a small exhibition of the cars used at the Cosmodrome. This is a GPM-54 armored fire truck based on a T-54. I want it. I want that car. Is that a Volga? Is that a Supra? Volga? GSE 69, nice. GSE 21 Volga and Maz 5667, which were used to transport people and cargo in the early days of Baikonur. Wow, they had a Volga to move people around. Well, shoot. Well, shoot. They must be freaking rich. Rich. The Volga's seen better days, though. Why an armored fire truck? Because you need to put out a fire. If you're gonna go near a rocket that's on fire, wouldn't you not want to be in a tank, Maka? Nice truck. I bet you it runs. No, we are rich. Yeah, right. This is a very special vehicle. It's a mobile control center made on the base of an ISU-122 assault tank frame and used in the Second World War. Any World of Tanks players? ISU-22, any good? They took off the cannon and made a safe armored command center that was used by Korolev himself. Cool. Hey Brady, what's going on? Cool. Yeah, they just took the turret off and just put a box. It was a TD? Cool. This vehicle is used to reach the landing site. Now it's replaced by the Bluebird vehicles. Dude. Cool. Yeah, Vulcan, it would be nice. I'd go with you. What is this? This is the Buran laboratory compartment. I'm not sure what it's called in English, so please tell me if I'm wrong. This could be placed into the cargo bay of the Buran. Oh, it's a space hab. Space hab. Yeah. Oh, no. I know what those are. Those are shuttle pallets. Shuttle pallets for Buran. Here's some of the... Here they have some flight-proven equipment with no signs on it, and I'm not sure what it is. The big grid things looks like it's part of the Buran cargo... Oh, those are Buran shuttle pallets. Why don't you become an astronaut? I don't know. Because raisins. Pressure vessels. They're cracked, though. No, I have an X. Balls. That looks like a TKS launch escape system. I don't know what the heck that is. They are Buran pallets. Oh, no. I don't want to see these. Why is everything outside? It's Baikonur. It's dry enough. And it's aluminum. I don't have to worry about it. It's not corroding at all. So these are the coupling mechanism that puts the so you can put cargo inside of the payload bay. The shuttle and Buran have similar payload integration systems. Basically, these pins go on either side of those pallets and they stick out like this, right? And then they set that inside of the payload bay, and the rails go into pegs that are on the sides of the payload bay. It's an active-passive latching system. I don't know what the Russians called it. Something. It's probably something different. You can reconfigure them. That's why it's called an active-passive latch system. So you could either put these things. So like I said, these triangle pieces would bolt to the side of those pallets. They would go right here. See that? You can see some of them have the pegs in them. Now, these ones are for passive latches, right? And the other ones are for active latches. These ones with the bumper right here. So these are passives and these are active locks. The shuttle uses something exactly like this. It's very similar. Why would you need an active versus a passive lock if you're deploying something in space? You need something that can clearance itself if you're trying to put it in and take it out of the payload bay. As opposed to the passive latches, which don't move. They stay closed. Yeah. The Soyuz scrubbed, yeah. I don't know what that is. I have no idea. Okay, let's go to Yuri Gagarin and Korolev's houses. 2 small cottages that were built in the early days of Baikonur and housed chief designer. Hey, that's Yuri at Yuri's house. This is cool, man. But it's a coffee machine. Yeah, probably. There's Korolev, chief designer. This is for Yuri Gagarin and German Titov. Yuri Gagarin was the first person to fly into space, right? And German Titov was the second, if I'm remembering correctly. Cool. This is the house where Korolev lived. Hey, not bad, not bad. Not bad for 57. You put a rug on the wall though. Got a nice fridge. Yeah. Alright, and now let me introduce you to Buran. To be precise, the OKML1 mock-up used for airframe and shaking tests. Okay, so it's an STA, structural testing article. You can enter it. There's an exhibition inside. Oh. Hello. Like Enterprise? More like Challenger in Aurelion. The Buran program's flight test article, the FTA, is in Germany. It's at the Technik Museum Speyer. This is an STA. So they would have used it's a structural testing article for vibration testing. Challenger was used for that in the US shuttle program. You notice how it doesn't have any RCS or anything. Challenger was just basically a bare bones space shuttle chassis, and they just put it on a huge paint shaker and shook it around a couple of times. And then after Columbia flew, what they were going to do is take Enterprise, take it apart, and then put it back together as a flight-ready shuttle. They didn't do that. They figured, we have a shuttle that has all this, the flight test article, it has all this stuff that's designed for flying in the air, but it doesn't have the tiles on it or anything. We'd have to take this apart and put it back together to get it to work. Or we could take Challenger, which is just a bare-bones chassis from the start, and just put together a shuttle. So instead of taking apart and putting together a shuttle, it's just put a shuttle back together. So that was why Challenger was the second orbiter to fly. They took the STA and they made it into a flight-ready orbiter. Some devices, a flight control system, gyro-stabilized antenna for the Kurs system adapted for Buran to dock to Mir. Hey, Kurs, they still use that. We watched the Kurz system automatically dock Nauka a couple weeks ago. There's Kurz. That's it. Oh, that's sick, dude. There's the gyro. That's the SAS for Buran. That's pretty cool, man. Yo. Gas turbine power plants. Turbines. Because they're the best. Inside of Buran, there's a mock-up of a satellite in the cargo bay. It is displayed like it would be in flight. Cool. Dude, that's pretty neat. It's not every day you get to see that. Here's the door to the middeck. Originally, it was designed for crew, but now you can watch a film about the Buran program here. It's a pretty bomb little museum exhibit. Are the seats on jack stands? Those are jack stands. Okay. You can also enter the flight deck. Whoa. Unfortunately, the control panels and seats are not original. They were taken from a plane. Close enough. Now, what plane? That's the real key. What plane do you think they were taken from? You got 4 throttle levers right there, so it's a 4-engine plane. Whatever they lifted these components from. I'm going to guess an Antonov 12. Hang on. Ready? Let's take a look. Let's see if we can look for the throttle quadrant on an AN-12. Nope. Nope. 747. There's no throttle quadrant on this thing. Where the hell's the throttle? There's a Fanta. Is that guy using a Fanta as a cup holder? Okay. TU4? TU4? Or no, not a 2. We need the 4. You think so? No, they're not. That's not correct. It's close. The throttle on an Antonov is an on-off switch. Yeah. I'm looking for the throttle quadrants. They must be on the outside on these planes. Here, let's take a look. Where the hell's the throttle? Oh yeah, it's out there. It's behind the yoke. There's the trim wheel. I don't know. Anyway, let's keep looking. Here's the body flap right there. Rudder pedals. You can see the top of the hatch for the ejector seat right there. There's the ejector seat hatch. Shuttle had these. Shuttle had a hatch like that. They never used them because only the first 4 shuttle flights had ejectors in them. They took them out. Just you don't need them. Try a Tu-95. I don't think they'd lift them out of a bear, but who knows? Am I missing something here? None of the Antonovs have the... Antonovs or Tupolevs have the throttle quadrant in the center. Where the hell's the throttle? Oh, it's out there on the right. Maybe. Oh, of course, the one picture we find of it is frigging potato. Lovely. Wait a minute. Wait a minute. That lever is longer than the other one. So this could be a 2-engine plane. I don't know what that lever would be for, but... Because those two are the same. And then there's another lever on the right, and I don't know what that does. I'd be curious to go and find it. DU-154 is close? Yeah, maybe. Maybe. I think the levers are original. Maybe. Yeah, it could be. There are some original details in the crew cabin. Yep, there's the hatch. I don't know what we're looking at there. Yep, isogrid. It's built exactly like the shuttle. It's the shuttle parts on the space shuttle look exactly like this. Don't ask me how I know. I said don't ask. Why would Buran have throttles? Maybe they plan to put jet engines on it. The flight test article for the Buran program had 4 jet engines on it, not 5, 4. Not 1 or 2 or 3, but 4. That's cool. That's a really cool little tour right there. Awesome. How you know this? Spent too much time looking at it. Anyway, guys, it's 7 o'clock. The Soyuz launch unfortunately scrubbed. So I think we should jump into playing some Kerbal now. That's the picture submitted that... Actually, yeah, it doesn't look like the levers were lifted from an airplane. Here. You know what we'll do? Let's do this. Let's look at the actual flight test article. Let's see. Maybe they lifted the controls from a plane for the FTA. So there's the flight test article. And it's in really good condition because they store it inside. Let's see. What is the inside of this? Huh. I don't think they lifted those. I don't think they lifted those, dudes. Tesla AI Day starts in 1 hour. Oh, dear. Oh, that's really cool. Oh, I'll check those out, yeah. Yeah, I don't think they lifted those, guys. I think that... Maybe... So that was OKMT1 or something? Nope. Yeah, okay. Hang on, let's go to Buran Energia. Okay, ML1. Okay. I'm just doing some research here real quick. I'm wondering if they were going to flight test all the different Burans. But then again, they sent one into space without flight testing it either. So maybe that's something with Buran's controls. I don't know. OKMT is the one that's in the, that's the one that's in the Urbex videos and stuff. Yeah, it's the one in front of Buria, which is that's 102, I think. No, hold on. Buran Buria? Snowstorm? Blizzard Storm? What's 201? Oh, I can't. No, I don't want to look at this. But I can't stop clicking. Why? Stop it. There's GLI right there. You're missing some parts. Ah, yes. Mark III cockpit being delivered to Jebediah's junkyard. 2011. Colorized. At least they put it back together. Is this thing just sitting outside? Oh. No. No. Yep. Not a fan of that. Thoughts on Energia Vulcan? Energia, but with 8 Zenit boosters. Yeah, that would have been pretty cool.